Bismillahirrahmanirrahim. Welcome to section 3.6, message passing. So message passing is a mechanism for processes to communicate and to synchronize their actions. Okay, the processes communicate with each other without resorting to shared variable. So variable here refer to the address space. Okay, they don't have to share address space between the processes. Message passing provides two options. Okay, send message and receive message. Message size is either fixed or variable. So short fixed length it depend to the message objective. If a designer want to minimize the processing and storage overhead, okay, they will opt for short fixed length variable. But if a large amount of data is to be passed, okay, so a designer will use a more flexible approach that is variable length messages. Okay, for message pass, if processes P and Q wish to communicate, we have two processes here. They need to first establish a communication link between them. Only they can exchange messages via send or receive operations. So for communication link, we refer to the next slide. So to establish a communication link, they are divided into physical aspect and logical aspect. So for physical aspect, it will be explained in details in chapter 19. So we skip this aspect at the moment. We focus on logical aspect. So for logical aspect, it can be divided into communication, okay, either direct or indirect, synchronizations, and also buffering. Okay. For direct communication, processes must name each other explicitly. So for example here, a sender must indicate the receiver process. Okay, so here sender send a message to process P, while for a receiver it needs to indicate the sender process. So in this primitive, Q the Q P process, the receiver, okay, receive a message from Q process, which Q is the sender. Okay, if we explicitly name each of the processes like this, okay, it is referred as a symmetric approach. We also have another approach which is asymmetric approach. So for asymmetry, we only need to indicate the receiver name, okay, but we don't have to we state the sender process name implicitly. Okay, so here instead of we put the sender process name, so we can use ID variable, so meaning that it can receive multiple receiver can receive multiple message from sender. Okay, multiple receiver can receive multiple processes, okay, from multiple sender. Okay, so both of the approach okay, before we discuss about the disadvantage of direct communication. Okay, we look at the properties of communication link for direct communication. So link for direct communication are established automatically once we name each other process. Okay, a link must associated with exactly one pair of communicating processes. Okay, each pair there exists exactly one link. The link may be unidirectional, meaning that one-way communication, but it is usually bidirectional, two-way communication. Direct communication has a drawback, okay, where the application programmer need to state the receiver and receiver and sender process explicitly. So it's quite tedious if a programmer want to modify the code. Okay, so that's why message passing offer another alternative, which is direct communication. Which is indirect communication. So for indirect communication, we will continue on the next video. Thank you, class, for watching.